Hello math enthusiasts, welcome to another video. In this section we're gonna to discuss about inclusion and exclusion. At the first step, let me to understand the formula, and the second part, let's go to the applications. You consider you have a class with A1 student interested to mathematics and the set A2 student interested to physics. You're gonna to calculate how many students we have, not only they interested to mathematics, but also they don't like physics. Exactly, this part is out of two sets, yes? But if we're gonna to formalize these, exactly is universal set is S minus union of these two sets, exactly this part. But if you see this intersection count twice, yes? Therefore at the last we must add this intersection. Therefore our total answer is ns minus na and a2 plus intersection of two sets. But can you tell me what's happened when we have three sets? For example, A1, A2, and A3. And exactly we're gonna to calculate this area out of these three sets. The formula is n, the total sets, minus union of these three sets. But if we're gonna to calculate these, at the first you must write ns, the total members, minus A1 and A2 and A3 with a minus, plus intersection of both of them, A1, A2, A1, A3, and A3 and A2. But in the last, I subtract by intersection of triple. Okay, let's go to the explicit example to understand this formula better. Suppose we have a set between 1 to 100 and we're gonna to calculate how many numbers are in this set such that they are indivisible to 2, 3, and 5. I call three sets. The sets A1, all the members are divisible to A2, all the members are divisible to 3, and A3, all the members in these sets also are divisible to 5. Therefore, we're gonna to calculate this set. Why? Because we're gonna to find how many members they are not divisible to 3 and 5. But in these sets, we have 100 numbers, and if we're gonna to find divisables to 2 is brace of 100 over 2, answer is 50. Another members are divisible to 3 is 100 over 3, and the brace is 33, but divisible to 5 is 20, but divisible to intersection, exactly because we had a 2 and 3 is 6, and 3 and 5 is 15, and also 2 and 5 is 10. Therefore 100 over 10, answer brace is 10. This one is 6, yes, and another one is 16. But intersection of triple, 2, 3, 5, yes, is 30. 100 over 30 is answer 3. Therefore, we must calculate all these members at the first universal, minus 50 plus 33 plus 20, but plus 10 plus 6 plus 16 minus triple is 3. But in here, answer is 103, and if we add these two parts is minus 3. Minus 3 and minus 3, they can cancel by 6. Therefore, total answer is 26. Okay, about the general form, how we must do that in general form. We're gonna to find all the numbers not only in A1, A2, but also in all variables. By previous formula, I can write it something like this: S minus union of all the AI between 1 to n, and we're gonna to write instead of these something like this: ns at the first minus with sum of all the subsets plus intersection of subsets and so on, minus 1 power n intersection of all n subsets. That is our general form. About the question 2, at the first we must understand what is that exactly. We have 18 identical bulbs and we want to distribute them in 4 boxes such that no box contains more than 7 bulbs. How many ways there exist? At the first I called box 1 by x1 and box 2 with x2 and box 3 by x3 and box 4 by x4. Our equation is something like this: x1 plus x2 plus x3 plus x4 is 18. If you consider we hadn't any constraints, is it something like this? And you know these members are integers, yes? By combinatory, we know the answer is 18 plus all the variables, 4 with minus 1, and in the bottom 4 minus 1, and that is combination of 3 from 21, and if you calculate this is 1330. But if we add the constraint, because all the bulbs must not be more than 7, exactly our constraint is something like this, between 0 and 7. But we calculate this part and we must add this constraint. Okay, suppose x1 is between 0 and 7. If we broken our rules, exactly x1 is between 8 and 18. Therefore, we add at the first 8 bulbs to box x1, and after that we start to calculating. Therefore, instead of this, when we broken our rules, is x1 plus 8, and if we put 8 to the left side, our calculation is this: x1, x2, x3, x4 is 10. Right now we hadn't any restriction, is 10 plus 4 minus 1, 4 minus 1. But you must consider for all these variables it can happen, and is combination of 1 from 4. If you calculate all these ways, is 4, and this one is 286. Total answer is 1144. But another one, you consider 2 boxes have more than 7 bulbs. In this equation, suppose x1 and x2 accept more than 7 and broken our rules, and we put this 16 to the left side. Therefore, our formula is this: x1, x2, x3, x4 is 2. Right now we hadn't a restriction, is 2 plus 4 minus 1 over 4 minus 1 times how many variables we have? Yes, 4. Therefore, the combination of 2 from 4, that is 6, and that is 5. Combination of 3, 5 is 10. Total answer is 60. What about the 3 boxes have more than 7 bulbs? It doesn't happen, because 3 times 8 is 24, as in more than 18. Yes, they never happen. Therefore, our total answer is, with respect to answer, of course, yes, therefore is 30 minus 1144 plus 60, and our total answer is 246. Thank you for watching this video. Don't forget to subscribe me. I'll see you in the next video. Take care. Bye bye.